Alright, now we're doing 7Q, Robinson Crusoe. This is by G964 and 82% of people like it. So Robinson Crusoe decides to explore his isle. On a sheet of paper he plans the following process. His hut has coordinates origin 0, 0. From that origin he walks a given distance d on a line that has a given angle ang with the x-axis. He gets to a point A. Angles are measured with respect to the x-axis. From that point A, he walks the distance d multiplied by a constant dismult on a line that has the angle ang multiplied by a constant ang mult, and so on and on. We have d0 equals d, ang0 equals ang, then d1 equals d times dismult, ang1 equals ang times ang mult, etc. Let us suppose he follows this process n times. What are the coordinates last x, last y of the last point? The function Crusoe has parameters. N will be the number of steps in the process, d will be the initial chosen distance, ang will be the initial chosen angle in degrees. So we got to do something about that. Dismult is going to be constant multiplier of the previous distance, and then ang mult will be the constant multiplier of the previous angle. Crusoe, all this should return last x, last y as an array. Here's an example of what it should look like. The x and the y should be this, wherever the end of it is, and here's what it looks like here. So basically what we're going to have to do here is we're going to have to find where the x and y are here, and then do the multipliers, and then find this one, and then the multipliers, and then the multipliers, and we have to find the, we just have to write a program that does this, basically, given all this stuff. I mean, that's why we're here, right? So, pardon me, let's get to it. First thing we're going to do is declare some variables. We're going to let x equal 0, and we're going to let y equal 0, because, well, that's what we're starting from, 0, 0. All right? Now we have to turn these degrees into radians, because we can't do math with degrees. We got to have radians. So degrees to radians is going to be degrees times pi over 180. And that's where we're going to use this Math.PI right here. And the Math.PI just puts pi into the function, into the program. So what we're going to do here is say ang times equals, and we're going to have that equal Math.PI. Make sure to make both of these capital, and then we're going to divide it by 180. Alright? That's not divided at all. That's not divided at all. Okay, there we go. Alright, so that's angle right there. It's going to be whatever the current angle is, whatever the starting angle is, times Math.PI times 180. Alright, now we're going to do a while loop, and we're going to say while in the number of times we're going to, the number of steps we're going to take, while n is greater than 0, we're going to do some stuff. And what we're going to do first is we're going to multiply the x, which right here on the first one is going to be 0, but we're going to multiply x times the, excuse me, we're not going to multiply, we're going to add to the x the distance times Math.cos of the angle. And we're doing that because, let me show you here, down here. Like right here, we're going to be looking for the x and the y. So all we have is the hypotenuse of any of these little triangles, right? So since all we have is the hypotenuse, we're going to have to, and the angle, I should say. We have the angle and the hypotenuse. So over here, because we have the angle and the hypotenuse, and we're looking for the adjacent right here, we're going to use cosine. So hypotenuse times cosine of the angle we have of the angle in radians we have will equal the adjacent. So that's what we're going to do. We're going to say x plus equals d, which is the hypotenuse, the distance, all right, times, what was it, Math.cos, because we're going to be using cosine, which is cosine here and sine here, Math.cos, and we're going to say angle, right? So we're going to do the same thing down here for y, except for since we're looking for the, we're going to be looking for the opposite, which is here. We're going to be looking for this one. We're going to use hypotenuse times sine of the angle, right? So let's come back over here. We're going to say plus equals d times math.sine angle, all right? Now I've got that taken care of. Now we have to update the angle because we're multiplying it by a multiplier. We're also multiplying the distance by a multiplier. So we're going to say angle times equals ang mult. That's not times at all. What am I doing? Times equals ang mult. And then we're going to say down here we're going to say d times equals dist mult. All right, and then we're also going to iterate to the next one down like that in the count, right? So all this, and then when we put it down here, because it's going to go through however many times through this whole thing, and it's going to end up at x, y. And that's what we want to return, all right? Test it out. All right, and it worked. All right, let's attempt it. All right, 32 milliseconds. There's no real good way to do a one-liner or concise syntax for this one. So we're just going to leave this as it is, submit it. All right, very much like this one. Let's go to My Solutions. Just me on this one. Best practice in my opinion. And we'll see you next time.